Okay, we'll do these plates on the outside. Go back to the skeleton. Select the plane, like said plane. Select the outside somewhere. There we go. Creates a plane. Turn the visibility off. Rename it. Work plane. Oh, side plate left. Edit. New sketch. Rotate around so I can see. Beautiful. I'll project through this line and this line. Draw a rectangle. Now instead of constraining corner to corner, that won't really work because we projected this plane, this part here, which projected it outwards. So if we put this corner on here, there's going to be no overlap, and then there's no real way of just screwing one part together unless we put angle in the corners, and then we'll add more bolts and stuff. Whereas this one here, I'm just doing ugly robot. So I'm going to constrain the top line to the corner, bottom line to the corner, and then make those there a distance of chopping board thickness. So there we go, an overlap. We'll do the same to the other side. Chopping board thickness, beautiful. And then I'm going to put in a construction line. Up, down, done, turn off, make the center line that, horizontal center line that. Draw a hole on each end. Up, top. Make those two fellows equal to each other. Make that dimension, well, we'll do fancy, we'll go half of that dimension. So there we go, so now they're sitting directly in the center. The hole size, we can make it the same as this one over here, which is, where is it? That dimension. There we go. Update. Looks a bit close to the edge. You know what? And that one there can be the same as this one over here. 50. There we go. And we do the same on the other side. We'll have our two mounting holes. Can make that construction line. Whoops. Random line. Center is horizontal. Its length is the same as the fellow on the other side. It is half of the thickness away from the edge. It's got a whole circle attached to each end of it. The circles are equal to each other and equal to the one on the other side. There we go. Finish. And there's a sketch for the side plate. Side plate left. Now I'm going to mirror it across the same way I mirrored those parts. So we'll just hit save, create new part, standard part, derive, find where simple's gone. And on simple, where'd you go? There you are. There's the skeleton opening. Turn everything off. Select side plate. Select chopping board thickness. Select extrude. Extrude everything we want the other direction. Chopping board thickness. Okay. Go for eye properties, physical. Scroll down to UHMW white. Apply. Close. Oh, forgot to mirror. Mirror that feature about the XZ plane. Okay. Wonderful. Save that as F005. And copy that into the main assembly. Paste. My properties. Occurrence 0, 0, 0, apply, grounded, apply, close. Awesome. We're almost finished building a box with motors in it. Do a bolted connection on the ends. Okay, start plate, circular reference, finish reference, select the other circles, select the bolt after it thinks for a minute, and then decides it can't find anything, and then thinks again. And then decides it can find something. Round head, thingy what's it, with a couple of washers. Fun, apply, okay, beautiful, other side. Start plane, circular reference, end reference, other circles. Select the fastener, think about it. Thinking, thinking, thinking. Come on, computer. Round head. Washers. Apply. Done. I don't like how close they are to the edge. We almost need thicker material. Maybe we'll make some thicker material. So we'll go back to our original skeleton, into the parameters. Scroll down to the chopping board thickness. Magically increase that to 12. Done. Update. Things move. The holes look much better now. Yeah, and those holes moved. They're now 6mm. They're in the center. They're in the center. Save that. Open this. Update. Ooh. There is one problem. I've always been annoyed with bolted connection. It makes putting bolts in so much quicker, but it never updates when you want it to. And I've always got these red lightning bolts, which means it needs updating. Which means you've got to edit it and then hit OK. And then it updates. Thank you for wasting my time. What over here? I think there's an automatic update button somewhere. It's here somewhere. There we are. Component. Automatic solve. But it doesn't automatically solve, does it? Where are you? Oh, there you are. You automatically solved. I don't know why it just doesn't select that to begin with. It makes things so much quicker to update, particularly if you've got 1,000 of these frickin' things to do. Sure, you have to sit there and wait for your computer to think for 10 minutes every time you hit update. Well, I'm patient. I'm happy to sit there for 10 minutes and make sure all the bolts are correct. I don't want to go through and do it manually. It's going to take 15 minutes. Some people just don't have patience. Enough rambling. There's my robot. It needs a base plate. Save it. Close the side plates. We don't need those anymore. We'll draw a base plate, which is pretty much the same as drawing side plates and everything. Select a plane that's parallel to it. Select a point that's on the bottom. There's a base plane. Rename it. Work plane, base plate. Done. New sketch. Select some points. So like that one there. That line there. That line there. Draw a rectangle. There's a base plate. It is a chopping board thickness away from there. Chopping board thickness away from that side. And that's a chopping board thickness away from there. And because I got nothing to measure to on the other side, we'll just make the center line of that line horizontal with the center line of that line. There we go. And I suppose we should screw this thing on. We'll draw a center line there, and a center line over here. Make the centers of those lines horizontally to the centers of those lines so they're equal. Make them equal to each other. Draw some circles for holes. Maybe if we don't make them construction lines, I might still be asleep or something. Put 6 in front and back, or 3 in front and back, 6 in total. Make all the holes equal to each other. This is exciting, isn't it? Make them half a chopping board thickness away from the edge. And same on the other side. Make that one there about 20 mil from the edge. There we go, all the holes have moved to the correct position, so now we just need a size. We'll make them the same size as the first hole we drew. I could make that into a parameter bolt hole size. But I'm feeling too lazy. This robot's not exciting me very much. There we go, there's a base plate drawn. Base plate. We'll make a parameter we'll just make it plate thickness. Maybe our newbie wants to use steel plate. It has some 3 mil plate lying around. Done. Update. Save. New part. Drive. Find where Simple's hiding. You're Simple. There you are. Opens the skeleton. Turn everything off. Select base plate. Select plate thickness. Extrude that downwards by plate thickness. And we'll make the plate out of I don't know. Aluminium? Maybe someone stole a road sign. Save. Frame F006. Save. Copy into here. Paste. My properties, occurrence 0, 0, 0. Rounded. Oh, look at that, we got a base plate. Ooh. I'm only putting the screws in the front and back plate. I don't want to put them into the motor mounts. So then the motor mounts would be harder to take out. If we want to remove the motors, all we have to do is pull the bolts off the front and back. We don't have to pull bolts off the bottom as well. Anyway, I'll do a bolted connection quickly. Circle reference frame. Circle, 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 circle. Come on, hurry up and select the bolts. Hurry up. Hurry up. Come on, faster. Faster. Yes. You're finally starting to listen to me, computer. About frickin' time. There we go, bolted the base plate on. Woohoo! Save.